Okay, IBAASL2, welcome back. Today we're talking about variance and standard deviation, which are pretty close to the same thing. One is, they both just tell you about the spread of the data. So in relation to a mean, variance and standard deviation, which are almost the same thing, and I'll show you with the equations in a second. They both tell you how spread out data is, whether or not it's clustered around the mean or whether or not it's kind of like spread out around the mean. So this situation right here on the left, it would have, I meant to draw this kind of, very tight around a mean being kind of the center of the data here. This would have a high standard deviation. Nope, excuse me, got it backwards already, Jolly. This is a low standard deviation. So low standard deviation means that it's clustered around the mean. Another way to say that is that it's not very spread out. Now this situation on the right, I drew it as kind of not as tall as the graph on the left, but there would still be a mean somewhere in the middle. And I meant to draw this kind of spread out, that it's not very compact around the mean, it's more spread out. So this would have a high standard deviation. Now, the way you find standard deviation and variance by hand is with these two equations. So, first of all, this is called sigma. It's a lowercase sigma. I know you guys are used to the capital sigma, which you actually see right there in the equation. But this is a lowercase sigma. It's like an O with a little hat on it. This is your standard deviation formula. Right next to it, we have the variance formula. Notice that the variance formula is a rho squared, or sorry, a sigma squared. The sigma squared, basically the same formula. It's just this one over here has a square root on it, and then if you square that square root, you get the same inside over here. So the one on the right is variance, the one on the left is standard deviation. They're very close to the same number. It's just one is a square of the other, but they both tell you how spread out the data is. So lower values mean it's not very spread out. Higher values means that it's more spread out. Let's look at what's going on in here. This looks scary, but it's really not. This means just adding together all the numbers of this type in the data set. Now, numbers of this type means that every score or value in the data set gets subtracted by the mean. I think we've used this symbol before, but this is a mu. Another Greek letter, mu. Like a kitty would say, mew, mew, mew. Yeah, so you take every score, you subtract the mean, you square it, and then you divide by your total number of data pieces. If you square root that number, you get standard deviation. So, real quick example of how to find this by hand. The book has like a data set of like 32 different numbers or something like that, but it's such a long table, so I really just boiled it down to like something simple, 2, 3, 4, 5, 6. The mean of this data, if you add them all together and divide by 5, is 4. So this part of the table means that you subtract the mean, the mu, the x bar, whatever you want to call it, off of each score. So 2 take away 4 would be this column, or this row right here, so this would be -2. 3 take away 4 is -1. 4 take away 4 is 0. 5 take away 4 is 1. 6 take away 4 is 2. Then you would take this entire column and square it to get the column next to it. So this is 4, 1, 0, 1, 4. Now, if I add those all together, that is going to give me the sigma I equal to 1 n of x minus x bar squared. So if I go back to my variance formula, what I'm finding is this whole top right here. I'm adding together all the x minus the mean squared. So if I add together 4, 1, 1, and 4, we get 10. That means that variance is going to be equal to 10 divided by 1, 2, 3, 4, 5 data pieces, which is 2. So 2 is the variance. If I square root that number, I get the standard deviation. So the square root of 2 is the standard deviation. So that's how you find it by hand. But just like everything in the statistics unit, you can do it on a calculator. The way you do this is you put all your data into L1, which I've showed you guys in other videos. You hit stat and then edit, and you put all your data in L1. If there's already data in there, you can clear it by highlighting L1 and then hitting clear and then pressing the down arrow. Once you've got your data in L1, you can hit stat again, calc, and then 1-var stats. You are familiar with this because we've done 1-var stats to find the quartiles and things like that. If you do that, here, let me see, I'll do it on mine. The 1, 2, 3, 4, 5th line down, you will see this symbol right here, sigma x. This is the standard deviation. So that's how you find it on a calculator. Now, IB likes to throw sort of theoretical problems at you guys without any actual data. So you can't do it on a calculator. You just have to reason and logic your way through it. So let's say a data set has a mean of 12 and a standard deviation of 2. A standard deviation of 2. I guess I should highlight all of it. There we go. If you take each value and add 20 to it, we need to find the new mean and standard deviation. Well, if you picture a group of data, you know, on a number line, and they're all like, you know, here, and then you shift them all by 20 this way, like whatever the mean was in the middle will just get shifted by 20 again. So the mean is just going to be the original mean plus 20. So the new mean is going to be 12 plus the 20, which is 32. Now, the standard deviation just tells you how spread out the data was around the mean. So if you shift it all by 20 up, you're not changing the spread of the data. So the standard deviation would still be the same. It would just be 2. It's got the same type of spread. You just moved it by 20 up. Now, the second question says each value gets multiplied by 4. Find the new mean and variance. So notice they're asking for the mean and variance, not standard deviation. So variance is standard deviation squared. If we multiply everything by 4, that's going to certainly multiply the mean by 4. You know, if you picture having a data set and each one gets multiplied by 4, then algebraically you can pull that 4 out of all of them, and it's just a multiplier. Like, you can factor it out. So the new mean is going to be 12 times 4, which is 48. Now, the variance is interesting because the original variance, like it says the standard deviation was 2. That means that the variance of the original is 4, because variance is standard deviation squared. Then, if you multiply everything by 4, you're actually going to have to multiply the variance by 16, because remember, the variance is the standard deviation squared. So, this is going to be the original variance times the new multiplier squared. Oops. Oh no, what's happening? Please stop. So this is 64. All right, you guys, that's all I got for today. Please ask questions in class.